Alright, so in this video, we're going to have a look at graphing using quadratic formula. Now, graphing using quadratic formula is essentially a variation on graphing with the intersections of the x-axis. But in the quadratic formula case, we use the quadratic formula to get those intersections. So this is something that we've seen before, but it is a different way of producing parabolas. So let's do an example. Let's do the example one here. What we're going to do is we're going to solve this using quadratic formula. So we're going to say y is equal to 0. I'm going to set this equal to 0, solve using the quadratic formula up here. So coefficient of the x squared is 2, coefficient of the b is minus 3, the c is minus 20. So we get our roots. Roots 1 and 2 are minus b, which is 3, plus minus the square root of b squared, which is 9, minus 4 times a times c. Well, 4 times 2 times minus 20. All negative is plus 160. This gets divided by 2a, which is 4. So this is 3 plus minus the square root of 169 on 4. Well, square root of 169 is 13. So this is 3 plus minus 13 over 4. So 3 plus 13 on 4 is 1 root. So root 1 is 16 on 4. And then root 2 is going to be 3 minus 13, which is minus 10 on 4. So 16 on 4 is 4, minus 10 on 4 is minus 2.5. So we've got our roots. This parabola, incidentally, we know is positive. It's got a 2x squared, so you know it's a smiley face parabola, it goes up. So let's graph the roots. Well, one of them is at 4, one of them is at minus 2.5. We said that it was a positive parabola. So we're just going to draw our parabola through, and it will look something like this. That's pretty good. And this is just an approximate graph. If you wanted to make the graph slightly better, you could use the vertex formula to find the axis of symmetry. You could actually find the coordinates of the vertex. You could use the y-intercept being minus 20 to say that this value is minus 20, and so on. But if we're just drawing a quick graph of it, you can use quadratic formula and the plus or minus of the squared term to find the intersections and to find the up or down curvature. So I'll let you have a go at an example. So I'll get you to do this one. So you are told to graph the following. Graph y equals minus 3x squared plus 4x plus 30. So I'd like you to pause the video now, have a go. Good luck. All right, so now that you've had a go, let's go through and graph this using the quadratic formula. So we need the coefficients, a minus 3, b plus 4, c plus 30. So roots 1 and 2 are minus b, minus 4, plus minus the square root of 4 squared, 16, minus 4 times a times c. Well, that's going to be 360, positive, because of the two negatives, divided by 2a, divided by minus 6. So now, this we can literally put in the calculator, right? We don't need to worry about simplifying these because we're just getting approximate values. So minus 4 plus the square root of 376 over minus 6 is minus 2.56. And then if we find the other root, we replace the plus with a minus in front of the square root. We get 3.89. And it has other decimals. So this is about minus 2.5. This is about, let's say, 3.9. So we'll graph these on our graph. Minus 2.5 is about here. 3.9 is about here. We know it's a negative parabola. It's a frowny face because it has a negative in front of the x squared. We also know its y-intersection is plus 30. So we'll label the plus 30 intersection up here. So we now sort of know what it's going to look like. The axis of symmetry will be roughly here on the graph. It'll be kind of in between the 2 points, exactly between them. And we'll get a curve that sort of looks like this. Down this way over here, and then it will go down this way over here. And this is our approximate graph of this parabola, which we got using quadratic formula.